Good morning, everyone. My name is Dominic John C. Mayol, and what I'm about to discuss today is the probability of union of mutually exclusive and exclusive events. So, the definition of it is two or more events are said to be mutually exclusive if they cannot happen at the same time. So, this is an example. Two mutually exclusive events A and B have probabilities. Probabilities A equals 110 and probability B equals 1.5. So what we're going to find is the probability A union B. This example represented as a Venn diagram. So probability A intersect B equals 0. It's equal 0 because they didn't overlap both circle. So probability A union B equals probability A plus probability B. So the probability A is equals 110 and probability B is equals 1 over 5. And probability 110 plus 1.5 is equals 110 to 10 because 1.5 turns into 210 because the fraction of 1.5 is 210. So 110 plus 210 equals 310. So 1 minus 13 is equals 710, and that's the union of the example. So the next is exclusive events. So two mutually exclusive events A and B. The probability of union of A and B is the sum of their individual probabilities. That is P A union A probability A union B equals probability A plus probability B. So the example of exclusive events is standard. Suppose we have a standard deck of 52 playing cards. So let's define two mutually exclusive events. So event A is drawing a red card, hearts of diamonds, and event B is drawing a black card, spades of clubs. We want to find the probability of the union of these events, which is the probability of drawing either a red card or a black card. Since red and black cards are mutually exclusive, a card can be both red and black. Their union covers the entire deck. So the probability of drawing a red card, event A, is the number of red cards divided by the total of the numbers. So probability A equals 26 over 52 equals 1/2. Similarly, they are similar because the probability of drawing a black card, event B, is also a 26. So 26 over 52 equals 1 over 2. Since events A and B are mutually exclusive, their union is simply the sum of their probabilities. Probability A union B equals probability A plus probability B equals 1 over 2 plus 1 over 2 equals 1. So the probability of drawing either a red card or a black card from the standard deck of 52 playing cards is 1 over a 1 or 100%. So this is an example of exclusive event. So the next is inclusive events. So mutually exclusive events theorem, probability A union B states that if A and B are events from a sample space S, then the given formula below suggests the procedure for getting the probability for mutually exclusive events. Probability A union B equals probability A plus probability B minus probability probability A intersect B. So this is example. So a class of students, we're interested in two events. So event A is a student who plays basketball, and event B is student who play soccer, soccer. So let's assume that some students play both basketball and soccer, meaning these events are not mutually exclusive. Now let's say in the class of 30 students, so 15 students plays basketball, including those who play soccer. 20 students play soccer, including those who also play basketball, and 10 students play both basketball and soccer. So to find the probability of union of these events, students who play either basketball or soccer or both, we use this formula. Probability A union B equals probability A plus probability B minus probability A intersect B. So probability A, student who plays basketball, blah blah blah, student play soccer, and student who play both. So substituting the values we have is probability A equals 15 over 30 equals 1, 2, and probability B equals 20 over 30 equals 2 over 3, and probability A intersect B equals 10 over 30 equals 1, 3. Now we calculate the probability of union. So probability A union B equals 1, 2 plus 2, 3 minus 1, 3. So probability A union B equals 3 over 6 plus 4 over 6 minus 2 over 6. So the final answer is probability A union B equals 5, 6. So the probability of union of events A and B, student who play either basketball or soccer or both, is 5 over 6. And that's the example of inclusive events. And that's all. Thank you for listening, and I hope you learned something.